study how to prepare potassium dichromate K2Cr2O7 from chromate ores. Step 1. Fusion of chromite ore with sodium or potassium in the free access of air. Let's heat at very high temperature the chromate ore and sodium carbonate. We can observe the formation of sodium chromate. The reaction is given by FeCr2O4 plus 8 Na2CO3 plus 7O2 gives 8 Na2CrO4 plus 2 Fe2O3 plus 8 CO2. Let's see the step 2. In the step 2, solution of sodium chromate is filtered and acidified with sulfuric acid. Let's pour dilute sulfuric acid into the yellow solution of sodium chromate. We can observe orange sodium dichromate getting crystallized. This reaction is given by 2 Na2CrO4 plus 2H plus gives Na2Cr2O7 plus 2Na plus H2O. Let's follow the step 3. In the step 3, the sodium dichromate solution is treated with potassium chloride. Let's pour potassium chloride solution into sodium dichromate solution. We can observe that orange crystals of potassium dichromate crystallize out. The reaction is given by sodium dichromate plus potassium chloride gives potassium dichromate plus sodium chloride. The orange crystals are of potassium dichromate. Let us study the properties of chromate ion. First, it has interconvertible nature of chromate ion into dichromate ion. We can observe that color changes on addition of either of H plus and OH minus ions. When OH minus is added, Cr2O7 changes its color. The reaction is given by Cr2O7 plus 2OH goes to 2CrO4 plus H2O. The color change is due to the formation of CrO4 whereas when H plus is added, again the color change takes place. This color change takes place due to the formation of Cr2O7 ion. Here, the structure of chromate ion and the structure of dichromate ion is given below. Let us study about the oxidizing property of potassium dichromate. Acidified potassium dichromate will oxidize iodides to iodine, sulfides to sulfur, tin 2 to tin 4 and iron 2 salts to iron 3. The half reactions are noted below. 3H2S goes to 6H plus 3S plus 6 electrons, whereas Fe2 plus goes to 6Fe3 plus 6 electrons. In acidic solution, its oxidizing action can be represented as follows. Cr2O7 plus 14H plus 6 electron gives 2Cr3 plus plus 7H2O with potential of 1.33 volts. Let us study the preparation of potassium permanganate. In the first step, fusion of MnO2 in the presence of an oxidizing agent takes place. Let's mix alkali hydroxide KOH and manganese dioxide MnO2 in a flask along with an oxidizing agent. Let's heat this mixture very strongly. We can see that the reaction takes place is 2MnO2 plus 4KOH plus O2 gives 2KMnO4 plus 2H2O. In the second step, disproportionation of potassium manganate in acidic or neutral solution takes place. Now, the potassium manganate is dissolved in acidic or neutral medium. We observe that the solution turns purple, showing the formation of potassium permanganate. The reaction followed is 3MnO4 2- plus 4H plus gives 2MnO4 minus plus MnO2 plus 2H2O. Let us study properties of KMnO4. It is isostructural with KClO4. We replace Cl by Mn to get the structure of KMnO4. The second property is that KMnO4 gets decomposed at 513 Kelvin. In MnO4-, pi bonding takes place by overlap of p orbitals of oxygen with d orbitals of manganese. Let's take acidic solution of KMnO4 in a flask. Let's take Ki solution in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. Overall reaction is 10I- plus 2MnO4 minus plus 16H plus gives 2Mn2 plus 8H2O plus 5I2. Let's see the details of the reaction which took place. The reduction reaction of permanganate to manganate in acidic medium. MnO4 minus plus 1 electron gives MnO4 2 minus. MnO4 minus plus 4H plus 3 electron first gives Mn2 plus 2H2O, then it gives Mn2 plus 4H2O. Now the oxidation reaction of Ki. In this 10I minus goes to 5I2 plus 10 electrons. On combining both the equations for reduction and oxidation, we get the major equation. Let's take KMnO4 in a conical flask. Then let us take FeO solution in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 5Fe2 plus MnO4 minus plus 8H plus gives Mn2 plus 4H2O plus 5Fe3 plus. For details of reactions, roll over the mouse on details of reaction. Let's take KMnO4 in the conical flask. Now, let's take K2C2O4 in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 5C2O4 2 minus plus 2MnO4 minus plus 16H plus gives 2Mn2 plus 8H2O plus 10CO2. Let's take KMnO4 in the conical flask. Now let's take KNO2 in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 5NO2 minus plus 2MnO4 minus plus 6H plus gives 2Mn2 plus 5NO3 minus plus 3H2O. For details of reaction, roll over the mouse on details of reaction. Let's study about the oxidizing property of KMnO4 in neutral medium. Choose from the following reagents: Ki, Na2H2O3 and MnO2. Let's take neutral solution of KMnO4 in a flask. Now let's take Ki solution in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 2MnO4 minus plus H2O plus I minus gives 2MnO2 plus 2OH minus plus IO3 minus. For details of reaction, roll over the mouse on details of reaction. Let's take neutral solution of KMnO4 in a flask. Now let's take Na2H2O3 sodium thiosulfate solution in the burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 8MnO4 minus plus 3H2O3 2 minus plus H2O gives 8MnO2 plus 6SO4 2 minus plus 2OH minus. For the details of reaction, roll over the mouse on details of reaction. Let's take neutral solution of KMnO4 in a flask. Now let's take MnO2 in a burette. After some time, we find that the color of the solution disappears, showing the completion of titration. The overall reaction is 2MnO4 minus plus 3Mn2 plus 2H2O gives 5MnO2 plus 4H plus. For details of reaction, roll over the mouse on details of reaction.